Welcome, everyone. I'm excited to kick off our presentation today on understanding the fundamental relationship in electricity. Today, we'll be exploring Ohm's law, a key principle that helps us understand how electrical circuits work. We'll cover the basics of voltage, current, and resistance, and see how they all connect. So, let's dive in and discover the fundamentals together. All right, let's talk about Ohm's law, a fundamental principle in electricity that helps us understand how electrical circuits work. Essentially, it describes the relationship between three key elements: voltage, current, and resistance. Think of it as a simple equation that connects these parts. The formula is V equals I times R, which means that the voltage, or V, is determined by multiplying the current, I, by the resistance, R. Voltage, measured in volts, is like the electrical pressure pushing current through a circuit. Current, measured in amperes, is the flow of electric charge. Resistance, measured in ohms, is the opposition to that flow. Understanding this relationship is crucial because it allows us to predict how changing one element affects the others, which is fundamental in designing and troubleshooting electrical systems. This concept ties into our overall theme of understanding how electricity functions and how we can control and utilize it effectively. Remember, the key takeaway here is that voltage, current, and resistance are interconnected, and Ohm's law gives us the tools to analyze and work with electrical circuits confidently. All right, let's take a closer look at some of the key variables in electrical circuits. First up, we have voltage, which is often called electrical pressure. Think of it as the force that pushes electrons through a circuit. The unit for this is volts, and it's what drives the current to flow from one point to another. Without sufficient voltage, the current can't move effectively. Understanding voltage helps us grasp how circuits operate and how to control the flow of electricity. This concept ties directly into the overall theme of how electricity moves and interacts within a circuit. All right, let's look at this practical example to understand how circuit calculations work. Suppose we have a circuit with a voltage of 12 volts and a resistance of 4 ohms. Using Ohm's law, which is I equals V divided by R, we can find the current flowing through the circuit. So I equals 12 volts divided by 4 ohms, which gives us 3 amperes. This means that a current of 3 amperes is flowing through our circuit. Understanding this helps us see how voltage and resistance directly influence the current, which is a key concept in circuit analysis. It's a straightforward example, but it really highlights the importance of Ohm's law in practical electrical work. Now you understand the foundation of electrical circuits. Thank you for your attention and engagement throughout this presentation. I hope you found it clear and helpful in building your knowledge. Remember, these fundamental concepts are the building blocks for more complex electrical systems. If you keep practicing and exploring, you'll gain confidence in working with circuits and applying what you've learned. Once again, thank you for your time, and I look forward to seeing how you use this knowledge in your future projects.